Hello everyone, welcome back to my another video. So in this video, I'm gonna walk you step by step how you can code your own AI agent using Python. So you'll understand that it's not that magical as you might think. You think that's kind of magic when you don't know how it works, but reality is different. These AI agents is also the LLMs, but simply their integration or functionality, how they are written, is very smart. Simply, there is a lot of blocks, function blocks or objects that simple LLMs use, and they decide which one to use, when to use, and etc. And in this video, you understand step by step how everything works. And it's crucial if you are using it, if you are a programmer, or simply you are thinking about project with it, if you want to improve somehow it. This way how the cursor was born. They simply saw that, for example, GitHub Copilot offers us to use LLMs to code, and they decided it would be better that they could use AI agents to, for example, analyze our code base before suggesting some kind of solution. And that worked. As you can see right now, it's billions of worth, the cursor. So that's crucial if you are working with AI agents. And not to take too much time, I want to mention that implementation of this AI agent is very smart. They simply use blocks. That's why you can find a lot of solutions online where they offer you to create your own AI agent using drag and drop. And that's true, you can do this, but if you're a programmer, it's crucial to know what's behind the hood. And with this tutorial, I'm gonna show you. That's not that magic, and it will work for beginners. If you are intermediate or advanced, you can keep watching it, but it's more for beginners who want to know how it works. So let's start with the first tutorial on the basics. And first thing, what we need to know is I'll demonstrate how to use OpenAI or to create your own AI agent. But first, we need to know how this kind of simple API request is made to our OpenAI client. Because if you can do this with OpenAI, you can choose whatever you want. So simply, if you're programming with it and Excel, you probably would already know how to do this. But for example, this is like a basic. You create environment variable where you define your API key, you define your model, you define your base URL, and that's it. You install the requirements. All the requirements will be necessary for all these 5 tutorials. That's not too much. And let's go to basics. And you can see that here I load the environment. This means I load this OpenAI API key from my environment file. And when it's loaded, I can simply send a request where I define that my system is a helpful assistant, and me as a user, I'm interested to write a 5-line poem about Python programming language. And that's it. And we extract this like this. And if I press run, it should work. Yeah. You may see it works. So it wrote this simple poem. In Python code, the logic flows. With simple syntax, progress grows. Indentation guides each line, a language clear, precise, divine, where creativity freely shows. That's beautiful. I can't even think by myself that. So that's pretty simple, yeah? So let's move to another crucial step. When we are working with these EA agents, it's like a mandatory to get the right output. Exactly the same as, for example, if we have a function in Python, which takes, for example, 3 arguments, name, date, participants, it's necessary to get the same structure from our LLM. And recently, not that old, the OpenAI introduced this new feature where we can get structured output using Pydantic. Before, we had to hard code a structure into the prompt to say you must return the response in a JSON format where there is a name, date, participants, and etc. And this way it worked, but sometimes it didn't. So we had to use some validation steps and etc. where we had to be sure that the response is in the right format. So right now we use Pydantic, and we can get this kind of very simple structure as we expect. So what we do, we import the base model from Pydantic. We import OpenAI, load environments, just like before. And here I created a format calendar event where we expect to have a name, date, and persistent participants. This is only an example for educational reasons, and let's move on. So we have this event and we define our prompt here. For example, the system must extract the event information from provided information. So, and my content is, for example, John and Bob are going to science fair this Sunday. Imagine that this, for example, content from an email or calendar event. We have a short description of what's happening, and we expect that our model would extract the name, date, and participants. So we feed response format, calendar event object, and that's it. And what we used before, we message content. Before we used completion choices message content. And right now we're using completion choices method passed. So this means that it passes the response. And that's it. If I'll run, you'll see that it will print event name, event date, and percent. Let's go and let's try it on. And that's right. You can see that science fair on Sunday and participants are John and Bob. So imagine that it might be other tasks, not necessary to have this like a content. You might have, for example, blog post where you want to extract 10 different stuff. For example, you want to extract blog content, blog date, the target audience, the tags, or the title. Well, there might be a lot of stuff that you might expect to extract from simple blog that you might use then to save this information into database. So that's cool. So right now, when we know how the structured response works, we might use it to another step using tools. So using tools is like how we say, we define function in Python. And for example, when we are solving a problem, we know what exactly function we want to use, in which order, and etc. So when we talk about AI agents, they also have the functions. They know what the functions are, and etc. But the difference is that they decide by themselves which one to use and what function at that time to use. So here comes the magic, that we are not hard coding the logic, but we let AI agent or LLM to decide what function, what tool, at what moment to use. And they can iterate until they completely finds the solution what we expect. As before, we import a lot of stuff. From Pydantic, we import this model field of the environment, import the requests, library, and etc. When we talk about this kind of tools, it's very useful to know the documentation. And here, for example, OpenAI provides a very clear documentation how to use tools and etc. So it's recommended to check this out. And for example, here there is an Anthropic blog post that is amazing when we are talking about AI agents. If you're thinking about creating something by yourself, I recommend reading this out. They'll explain us how they use tools, memory, retrieval, what's the practical side of using them. And it's totally recommended to check this out. So let's continue with our code. So right now I define my client. For example, I define a get weather function. That's like a simple Python function that's open source, like an API where you don't need to sign up anywhere. And we need to provide latitude, longitude, and we'll get back the information from that longitude, latitude as a weather. For example, Celsius, pressure, and etc. So we define this, and then we define this kind of tools. As saw here right now in OpenAI, you saw very similar stuff. So simply I can copy this, paste this, and we need to change some parameters. For example, we need to change the name of this function as it's getWeather function. We need to modify the description. It should provide us coordinates in Celsius. I mean, they should provide a temperature for provided coordinates in Celsius, right? What parameters I feed to this function, because it's an object and it expects to have a latitude and longitude as numbers, and they are required and not optional. Additional properties are false and the structure is strict. That's cool. And we define this tool. And next, we define this messages, where system message is your helpful weather assistant. That's logical. And message user, what's the weather like in Paris today? Our question. It might be any. What's the weather in Berlin? What's the weather in New York? What's the weather in any country? But keep in mind that right now, I'm asking only for the capitals that I'm sure that OpenAI knows these coordinates in latitude, longitude. Otherwise, it might not provide us the right answer. So we define our model, client chat completions create, and here we define our tools. As before, we were creating this one, completions pause. Right now, we completions create, we define our models, messages, what are messages, and what tools we are using. We'll see what I mean here. So here we call this, and we can actually go here within the debugger. So create the launch, Python debugger, Python file, cool. Yeah, and I'll run this and stop here. And what we might see here is there's a lot of stuff happening here. Yeah, it's not that great to read this file. Let's see, maybe I can print this as object. Yeah, cool. You might see this an object, and you might see that it responded, the completions responded us with ID choices that it calls a tool call and gives the log probabilities and etc. The modal, chat completion, default, and etc. So this tells us that it decided to use our tool calls. And let's see deeper tool call. Okay. Yeah, that's only a tool. So right now we define our call function, and here I define this function, and here I have a get weather with arguments. And if we decide to have, for example, more tools, we implement it here within the different names. So cool. Right now, let's move on within this code, and I'll show you how it works. So this is the completion choices measure tool calls response. And here it responded that it is using the tool calls. And what are the arguments? Latitude, longitude. What is the name? This is the name of the tool calls it's expect to use. And what is the message? Let's see. Let's print this out. Yeah, it's kind of like an object response. That it's our arguments. Actually, that's the same stuff. So that's cool. And now we know the name and args for our function that goes here. And let's go deeper. And you know that here comes the name and arguments, latitude, longitude, and it returns us results from get weather as arguments. And the results are the in temperature and wind speed, time, and etc. That's nothing magical. Yeah, and we simply append our messages and tool calls finished iterating. And now we have our response from our API. And we need to structurize the response from our OpenAI model. So we define a class weather response model where we want to respond with an actual temperature in a number. Here is a float, and maybe natural language response to the user question. So that's what we define, and we actually do the same as before. We give it a tools, weather response, and what are the messages. This is already messages with like a memory of information, what we already got back from our previous response, and move on, and that's it. And we receive the completion pause response, and what it is, let's see. Pom, pom, pom. You might see that the temperature is 15.1 and the current temperature in Paris is Celsius with moderate wind speed of 30.7 kilometers per hour. It seems like a mild day today. So let's check this out. Temperature in Paris now. For example, what it will open, it's 15 degrees. That's exactly what we got from our OpenAI response. That's cool. And that's not magical. As you might see, we have the tool function, and we simply need to use this in the right order. So cool. Now you know how to use it. Let's go with another function tutorial for this is our retrieval. So this request is not used here. Imports all the same as before. What is retrieval? If I open my Anthropic blog post, you might see that there is retrieval tools and memory. So you might already know what are tools. This is a weather function or any other function would be in memory. So we simply stack our memory into some history and etc. And retrieval is some kind of database browsing, website browsing. Simply, retrieval is meant to find data externally. So you'll see. So for this example, for example, here I have database JSON. That's like internal knowledge base, where, for example, this is an eShop policy. For example, what returning policy, shipping stuff, payments, and etc. Usually, when we are dealing with eShops, there is hundreds of similar questions that should be answered. Here, we could use our AI agent as chatbot to help us to respond on our client like this information. So if I get here I have a search database function, and it might be anything. It might be search online, search anywhere. So for example, here for simplicity reasons I have JSON, but usually if you are dealing with a huge database, it might be like a vectorized database for easier stuff search, and there could be a RAG combination, etc. So simply we define this search DB function. Here I have another tool call for search DB, and here's I required a question. What is the type? That's the string. Get the answer to the user question from the knowledge base, and here's a search DB function. As before, that's the same. We define this tools record, and then we define a system prompt. You are a helpful assistant that answers questions from knowledge base about e-commerce store. So yeah, cool. That's what I said before. And what's the return policy? For example, if we ask this straight for our LLM, it don't know this information because each eShop might have different return policy, and we need to find this information from the knowledge base. So that's why we define it. So as before, we define our client chat completions crate with a message and tools, and here we get the response that's actually the same as before. And also here is actually the same as before. We decide that it needs to search for this kind of tools, and this database response tool should answer the user question and return it. And of course, it should return the record ID of the answer, and that what we're gonna get. So, and then as before, assume if I open this side by side, you will see that's actually all the same stuff. Instead, before we had a weather response here, and right now we have a database response here. And that's it. And we get the final response here, and it will give us an answer. So let's run this in a debug mode. Cool. Let's move on. You got us a response, final response. What it has a source 1, and answer item can be returned within 30 days of purchase with an original receipt. That's cool. And we return this response. What else we do? Yep, we got the final response here. As you might see, if item can be actually answered the user. And here is an example what happens if the question doesn't match within the knowledge base. So here I have the same system prompt, and for example, user asks what's the weather in Tokyo instead of saying that what's the return policy. Yep, let's move on, and we actually use all the same stuff here. And what's here, let's print this out. I currently don't have access to real-time weather information. You might want to check a weather website or app for the latest date on the weather in Tokyo. If you have any question about our product or service, feel free to ask. That's a direct answer from LLM. And you might see if it would have some kind of tool to use weather, it might use it. But right now, as it don't have real-time tools to use, it simply responded with this kind of response. And it doesn't match with the knowledge base, tools, and etc. So that's cool. So right now, we know how to use basic requests to LLM, how to get a structured response, how to use a simple tools, and how to use a retrieval. So next thing, this is the last example, I'll show you how to create a more advanced example. For example, how to use few different tools, because usually here comes the question when the user by itself tries to implement this. It kind of looks very basic when we use one tool or another tool for simple problems. But what happens if we need to use a few different tools. Here comes the challenge, and user don't know how to do this actually. So let's go to the tool chaining example. This is the last example here, and I structured the code here and documented it, and not going step by step right now, not explaining all the documentation what I wrote, because I try to document it and write it in a more object-oriented way. So when you open it up, you can continue working on it, creating more tools and etc. That's only an example. What's the best practice with AI agents, where you should start creating them. And as before, we use base model field. Here I imported math. You'll see why. So as before, I'll use a weather tool to get our response. Here I define it as an object and I document it. I define the name of it. I define the call function. Up to here it works actually the same as before. It requires latitude, longitude. There's a lot of documentation, etc. What actually happens, and what it does, it, as before, it does the request to this weather API and simply gives us a response. Well, there's huge error handling stuff and etc., but that's not the point here. So it returns data and current. Actually, that's the same as before. It was returning data and current. Next, I added additional tool function into this object that we call. So this means that always when we create a new tool, we need to define this tool parameter. So here it automatically creates a name and what requirements and etc. So this means when we're creating a new tool, for each new tool, we need to define this tool, that we don't need to separate it from this tool, because usually it's very hard to find the end and start when we have hundreds of these tools, for example. So this is the one tool, and as an example, I decided to use another tool. It's a calculator tool, and what it gets is an expression. Well, there's simply a Python code to validate what comes here, and that's it. And here comes the expression. That's for an example expression is like this, and that's error handling and etc. And then we move again to the tools where we define what should be an input. For example, 23 plus this one, mathematical expression required and etc. And you see that's nothing magical. And what we expect from the final response, we want to get the final numerical result of the calculation of the temperature. So the task is to calculate what's the sum of weather in different capitals. For example, it might be, well, this is just an example task. So this means that, for example, if we feed two capitals, for example, Paris and New York, the tool should find out by itself that it needs to find coordinates for Paris, get the weather for Paris. Then it needs to find the coordinates for New York, get the temperature for New York, and last it needs to sum the result and then respond it to us. That's if we would like to make it even harder. For example, if we will choose capitals that LLM don't know the coordinates, we need to use another tool that extracts the latitude, longitude from provided address, for example, and then it moves on within this chain. So cool. And then I define an agent that, well, the client, system prompt, tools, model, for example, what model to use, debug. It's very cool when you're a beginner and you don't know how it works. If you press debug as true, it will display the whole logic, how it decides what to do at each step. So it's initializing tools, for example, as before we provide the tools, and because each tool, an object have its tool, like a parameter, function, it returns this information that it must know. Tool definition and etc. So this is debug, and here's call tool by name, and that's it. And because what are the tools, we know the name and we call it by name, and that's it. There's the whole logic that, for example, as I said, we don't know. For example, user might even provide 5 capitals, 10 capitals. And this means that the AI agent needs to keep in loop to find all the necessary information to move on with these tools. For example, it finds the Paris weather, it finds the New York weather, it finds the Berlin weather, and etc. And only then, when it has all this information in memory, it can move on within the sum. So it needs to iterate. Here comes the flexibility that it would be really hard to hard code when we are working with a pure basic Python. So you can open the code and you'll understand how it works by yourself. It's only an example, but I do recommend to move on with this example if you are just interested to implement something like a hard. So, and here comes my code where I would like to show you how it works. So we defined a system prompt, your helpful assistant who can get weather and do calculations. Well, we can right now with this, we can move in two ways. We can ask for calculations and not to ask calculation. Well, but it can do. So maybe it should be hard-coded prompt into the AI agent that has this also. But because I made it in a way that it's flexible, we decide what tools it will have. In this way, we need to construct the system prompt also by us. And yeah, and if I'll ask what's the sum of current temperature in Paris, Belgium, and your work, let's start it with a simple task. Yeah. So if I run this code, okay, was it running? No. Yeah, here it starts. And yeah, the result is 32.9. The current temperature in Paris is 15.5 and in Berlin is 17.4. The sum of this weather is 15 plus 17, and it's like this. So this means this result got from weather API, this result we got from weather API and tool, and this result we get from calculation API. It decided what to use by itself. So cool. Right now, let's look with a debug option as true what it does. There will be a lot of steps. And this comes a drawback that usually there's a huge task we need to do. There's a lot of requests going to OpenAI. And if it's, for example, slow, as for example, DeepSeek API, we are using this with local LLMs, it might take some time to get the response. Here comes the drawback from AI agents, but I'm talking about now. Who knows what will happen in 5 or 10 years? It might be an instant. So yeah, cool. And you might see that you can go step by step what will happen. Here we define it, sending message to, and yeah, sending it to the weather API tools, response from tools, another tool with another location, response, and then sending again this expression to another tool, calculate this and got the results, aggregate these results, and give us final results. And you might see that it works. And right now I can, for example, add another example. And New York, I'll turn this off for simplicity reasons, not to floor my terminal. And yeah, you might see that's amazing how it works. The result is 46.4. And it returned all these responses. As you may see, that's not a magic. It's simply a smart placement of each tool, the logic in the code, and etc. And for example, one more thing we need to test is what if we are not interested to have the sum, but simply we want to get single temperature. In New York, for example, 12.4 right now is there, and the current temperature in New York is 12.4 degrees in Celsius. And this means it haven't used some tool, it simply got the weather from first API and it understood that that's it and simply gave us the response. And that's all the magic we need to know about AI agents. Right now, you need to decide what's your task, what's your problem, and to move on with this. Move on, like solve harder tasks and etc. So that's it about this tutorial. I want to demonstrate that it's really very simple. And if you like this content, don't hesitate to smash the like button, subscribe, and continue to follow my channel. I'm eager to create very similar great tutorials that would give you a deep understanding of how what works. Right now my focus is AI agents, to get a few more tutorials about AI agents, to get you more background understanding, what they are, how do they work, where we could use it, and so on. And in this example, I wanted to show you what they are from practical side. Right now, it would be interesting to find some kind of real world problem that we could create AI agent for. So if you have any idea, don't hesitate to write this in comment, and I'll think maybe solve your problem if you have one that you're trying to solve. So that's it about this tutorial. I hope this was useful for you. You can find all the links in the description related to this video tutorial. I'll post the code into GitHub, so it will be easier for you to catch up with it. And that's it. Thank you all for watching, and see you next time. Bye.